So there are plenty of problems in your practice test. Okay, so I'm going to post my, whole work of these solutions. In today meeting, I'm just giving kind of, you know, hints, and let's see if there's any difficult problem, then I will work through that problem. Okay. So could you identify what kind of derivatives the first problem had? Okay, before going to do, so what are the things we need to look at for this test? For test 1, we need to cover from 5.1 to 5.8, right?
Yes.
Okay, so the 5.1 is about natural logarithm. Then after that, we studied about the exponential function, then the differentiation of logarithm, then differentiation of, exponential, then integration of log, integration of exponent, those things, right? Then we use the logarithm technique, logarithm differentiation technique to find out the first derivative of kind of complicated functions. Then after that, we had the inverse function, then how to find the derivative of inverse function, and so on. Then after that, we need to look at the inverse trig functions. Before that, the L'Hopital rules, right? Do you know where we use this L'Hopital rule? Any idea?
In real life or in
No, no, in this particular application, where do we use these L'Hopital rules in this particular class notes?
5.7, I think.
Okay, L'Hopital rules we use when you find the limit, okay,
Yes.
limit of two functions with ratios, or suppose if x goes to some particular value, say c, if you are asked to find this kind of limit, if you have this kind of situation when you do the problem, if you come across like this 0 over 0 or infinity over infinity, if you have like this answer when you're plugging c into your two functions, then these kind of values are called indeterminate, right? You cannot find the answer.
Correct.
So if you have such a situation, you have to somehow use some technique and find the real answer. You need to find the real value. So your final answer may be any real number, okay? Or you may have infinity, no problem. But you can't have like this situation, 0 over 0 or infinity over infinity. So if you have such a condition, then we use this L'Hopital rule to find out the limit of the, two ratios, ratio function like this. We call rational function, right?
Yeah.
Okay, so the L'Hopital rule says that if this is the case, if you come up with this type of scenario, then finding limit x goes to c of fx over gx will be equals to find the limit of the first derivative of these two functions. That means f prime x over g prime x, right?
Yeah.
Okay, so this is equivalent to that. Suppose if you come across this kind of situation, then simply find the first derivative of these two functions, then find the limit. Again, if you get 0 over 0, then keep on doing. Take one more derivative of f prime and keep on doing until get real or infinity answer.
Okay.
Okay, so why don't you go through your lecture notes? I believe this is coming from
5.6 or 7, one of them.
5.6, I believe. Yeah.
I remember my professor, Dr. Panther.
Okay.
He had went over, I think, 5.6 with us during Cal 1.
Yes, you might have learned in Cal 1 about using L'Hopital rules. Yes, you're correct.
Yeah.
Yeah, so you could go through there and check. Okay. Now here, so let me give some brief introduction. So finding the first derivative, that means what? You are asked to find y prime for all the problems. Okay. So if
Mhm.
you look at all the problems up to part E, you have ln. So that means you have to use the derivative of natural logarithm. So if you look at the function inside, you have some other than, you, so you could keep this as u, get u, keep this as u, use substitution to find the derivative. Okay. So if you look at the note, so refer your note, finding the derivative of a natural logarithm. Remember, d over dx of ln of any function u could be any function, in terms of x. This is nothing but 1 over u times u prime. Remember that formula we learned?
Yeah.
Okay. We have one more formula. This formula can be applied even absolute u also. You will have the same answer. You may have absolute here or without, but our answer is still same, right? So use these, fundamental formulas to do first problem. Okay. So you are given all the answer keys, and there are a couple of errors in the answer key, and I'm going to upload, my solutions maybe later tomorrow. You could go through my answer with your work, and if you have any doubt, let me know. Okay. So now I'm going to do one or maybe couple of problems from first one. So could you pick two problems from first one? Which one do you want me to do?
Let's do. We'll start with C.
C.
Yeah.
Okay. So problem number one, part C. Let me write down the problem first. So you need to find the derivative of this complicated function. 4 minus x square root over 2x plus 1. Right? If you see kind of, a over b or a times form inside the ln, you could use the log property. The log property says that ln a over b is simply equals to ln a minus ln b. Do you remember this property?
Yes.
If you have division inside the log, you could split into subtraction. So that means if I write that here, you will get ln square root 4 plus x squared, then subtract ln 2x plus 1. Remember, square root means nothing but to the power of half, right? That means, again, use the log properties for the exponential. If you have exponential inside the log, you could pull that, that exponent in front of log. So this is just half of ln 4 plus x squared minus ln 2x plus 1. Still, I did not find the derivative. I simply expand the given problem. Okay. Now find y prime. First, find the derivative of, the first expression. Half is constant. So you need to find the derivative of what? ln 4 plus x squared. Then subtract, find the derivative of the second piece, which is ln 2x plus 1. Now you need to find one by one. First, let us find this first derivative. Now you need to take, so I'm using u substitution, right? So this is u. So if we apply this formula, apply formula number one to find out the answer. If this is u, half is outside, right? d over dx of ln u is simply 1 over u. So 1 over u, our u was now 4 plus x squared times
2x.
u prime. U prime means what? The derivative of inside function. What is the derivative of 4 plus x squared? What's the derivative of 4 plus x squared?
Oh, 2x.
2x, yes. Then subtract, again use the u substitution. This is the u for the second piece. So that is again 1 over u. U is now 2x plus 1. And the times u prime is simply q, right? That's it. Now you have to simplify and find the answer. So 2 gone, you will get x over 4 plus x squared and minus 2 over 2x plus 1. Okay, so if you want, you could combine these two. The LCM is just a product of these two. So I'm just combining these two rational, functions. So you know you have to cross multiply, right? So x
Yeah.
times 2x plus 1 and subtract 2 times 4 plus x squared. Now you need to distribute inside and simplify. 2 times x squared, 2 x times 2x is 2x squared, and minus x times 1 is plus 1, sorry. Then minus 2 times 4 is 8, and minus 2 times x squared minus 2x. So over what? Oh, this should be x, right?
Which one?
2x squared plus x, I missed that x, and minus 8, and yeah. So now this all over 4 plus x squared times 2x plus 1. Now simplify. 2x squared gone. So simply x minus 8 in the numerator. And did I miss any negative sign? No, right?
Nothing.
That makes sense?
Yeah, we can just keep it like that, right? And then simplify the bottom.
Oh, I see. I think I made a little bit small mistake here. Do you see that mistake?
Oh, you forgot to put
This is negative sign,
minus.
right?
Yeah.
Negative.
Oh, yeah, but I understand it though.
Yeah. So I missed that negative sign. So that means you will get one negative sign here when you find the chain rule. Okay? So that is there. Anyway, I'm going to give the answer solutions in detail. Okay, I will upload tomorrow. You'll see. First, just make sure that you understand the concept. Okay, so one more problem. Let us look at which one is harder. E. So E, y was ln 1 plus square root cosine x. So my u was this. This is my u, right? If that is u, then what is u prime? Could you tell me what is the derivative of 1 plus square root cosine x?
That's like a chain rule, so then it would be
Um,
just
Yeah, the derivative of 1 is 0.
yeah. That'd
But
be like
here, yes, you have to use the chain rule. Derivative of the square root function. Remember, the derivative of square root x is 1 over 2 square root x. Do you remember?
Mhm.
Okay, if here you do, if you have u, then here you have to put u. So now use the chain rule, but again, you could think of this all like u. That means the derivative of square root u is 1 over, I'm using this, simply replace, inside function by cosine x. You understand what I mean? So you should get like this. Then times the chain rule, inside function derivative. The derivative of cosine is negative sine x. Does that make sense? Inside the u, again you have to use one more time u substitution, right? So when you find the derivative of this guy, again you have to keep this as another u 2 times, right?
Mhm.
So then you will get u prime as like this. Now go to the problem. If this is u, the problem is simply finding the derivative of ln u, that is 1 over u, where u was this all, 1 over u times u prime, right? So simply plugging the u primes.
So it's negative sign.
So u prime was here. So you will get negative sine x. You're multiplying, okay?
Mhm.
So negative sine x over 2
2 cos x.
cosine. Now simply move this constant in front of the fraction. So you could write negative half sine x over 1 plus square root cosine x times square root cosine x. Okay. So if you want, you could distribute with square root cosine x inside and simplify it. So that means you will get negative sine x in the numerator over these two is here. When you distribute 1 with the square root x cosine x, you will get square root cosine x plus when you multiply square root cosine x times square root cosine x is simply cosine x. You see that answer, right?
Yes.
That is there for the first one. So use like this for all the problems. What is your trick? Trick was to use the formula ln u and the chain rule, right?
Mhm.
Right.
But is it okay to leave?
Could you talk a little bit louder?
Oh,
Yeah, sorry.
I said, is it okay to use the or keep the negative 1/2 or like negative sine x over 2
Yeah,
parentheses?
that's up to you. Yes.
Okay. What is the test going to be like? Like you did during statistics, or is it going to be on?
What's that?
Is the test going to be on Georgia View or?
Yes, I'm going to upload the test on Georgia View. You see you know, the Dropbox there, right? Under the assignment.
Yeah, oh, so it's going to be like statistics then.
Yeah, the test will be available. You will see under the class test folder. There's a folder under the content. Do you see that?
Yeah.
Yeah.
Okay, I was just making sure. 'Cause I know
Yeah.
sometimes.
Yeah. Anyway, I'm going to give you one instruction before starting exam. I will explain everything clear. Where do you find the exam and how to upload and all the things.
No,
Okay.
because, yeah,
So
because sometimes.
the test will be available maybe midnight of of 30 August 30. So you will have until the next day 31st until night 7:59. So you
Yeah, I
have
just
to,
wanted to make
yeah.
sure you were the one grading because I know sometimes whoever sign asks for like a specific
Ah,
simplified.
yes, yes. This is I'm grading all manual.
Okay, that's good.
Yeah. Okay. Yeah. Web design is kind of they have a lot of problems.
Yeah, they want a specific one answer, even
That's
if
the
it's
thing.
like
Yeah. Even though if you make small mistake, it will not.
yeah, that's a problem.
Right. Okay. Let's move to now second one. Do you have any question? If you have particular question, could you ask me? The second one. Again, second one, but you have now more work. The second one is about finding the first derivative of exponential function, but you have to use some, the Cal 1 things. That's kind of product rule, quotient rule, like that, right? Chain rule. Yes. So now some problems are kind of tricky. You have to use everything together, right, to find the answer. So I'm giving some hints. So for the part 2, problem number 2. Problem number 2, use the derivative of exponential x. What is the derivative of ex? Ex itself.
E times, yeah.
Yeah. So you see, I already have posted that formula sheet, right?
Yeah.
Keep with you. You have everything. Okay. So make sure that you have it. So now where are we? We are in exponential. So you see exponential.
You're right there.
Yeah. So
EU
now
times U prime.
u prime. Suppose if you have x here, simply u prime is the derivative of x, which is 1. So you will get simply e to the power x.
Okay.
Okay. So make sure that you have it this. When you do the test, you can keep it here. So that is the derivative of e to the power x, right? Okay. Suppose if we have u here, the derivative of e to the power u is simply e to the power u times u prime.
Yeah.
Suppose if you have exponents other than e, say some other number a, then this is given by a to the power x times ln a. Right? I forgot to tell one thing here in first problem as well. All the problems are ln except the last one. So last one you have to use the differentiation of the log other than the base e natural. Yes. So go back and check. You have one more formula to find the log with any base a. You remember the answer? That is
Can't
1
you
over u times ln a times u prime.
go long?
Yeah. So in this case, in problem, the last problem, your a is 2. Here you have 2. Your u is this function. So you have more work now. You need to find the first u prime. U prime is the derivative of square root 1 plus x squared. Find that, okay?
Yeah.
So u prime is the derivative of square root 1 plus x squared. That should be 1 over 2 square root 1 plus x squared times inside function derivative 2x. You see that?
Mm-hmm.
If this is u. Okay.
Yeah.
Then after that, yeah, simply plug in the values. What is a here? A is the base. This problem a is 2. So plugging a2 here, u is square root 1 plus x squared and u prime is this, and after that simplify and check the answer. So the given answer, there's a typo in your answer, no problem. For time being, you could keep your answer, then you could compare with my one, okay?
Okay.
Right, so now use these two formulas to do the problem number 2. Okay, so now with that, you need to use chain rule, product rule. Okay, so let's do some of these problems. So let me try, say B. Find the first derivative of the following functions. So B is y is equal e to the power negative x times cosine 2x. How do you find the derivative of this? Remember, you have now two functions, product, right?
Yes.
You have to use what?
Product rule, right?
Product rule. So you could think of this is function f, this is function g within multiplication sign. So y prime is simply product rule, f times g prime plus g times f prime. This is product rule from Cal 1, right?
Mm-hmm.
Okay, my f was e to the power negative x and my g was cosine 2x. Only you have to find those and simply plugging the values, right? Okay, now tell me, what is f prime?
F prime
Our
is,
function f is e to the power negative x.
yeah.
So then what is the derivative of e to the power negative x?
E to the negative x times negative 1.
Exactly. So you could think of this like u, right?
Yeah.
So the problem is like finding the derivative of e to the power u, which is e to the power u times u prime. So e to the power u is negative x times u prime is simply the derivative of negative x, which is negative 1. Okay? So that is our f prime. Then what is g prime? G prime is the derivative of second function, cosine 2x. What is the derivative of cosine 2x? Sine 2x times times
2.
inside function 2x derivative is 2. That's it. You know two answers, simply plugging into this formula to find y prime. Therefore, y prime is, I'm using this formula. So y prime is f times g prime. F was e to the power negative x times g prime. G prime is that. Let me write down 2 first and sine 2x. So f times g prime plus g times f prime. So g is cosine 2x times f prime. F prime is negative e to the power x. No confusion, you are multiplying, okay? So could you simplify this?
Oh yeah. We can cancel out the, what do you think?
You see now, e to the power negative x is the common factor between these two expressions, right?
Oh, take that out.
Yes, I could pull e to the power negative x as a common factor. So the remaining piece here is leftover is 2 times sine 2x. And this already taken out, I have negative sign, but you are multiplying, so minus into plus is minus cosine.
Plus 2x.
Okay, so that is the answer for part B. But if you look at the answer, in the answer sheet you have here negative sign because they have switched these two. So this is correct. If you want, you can step at this point.
Okay.
And that is about number 2, part B. So, okay, let us do the last one.
Mhm. Well, that was kind of easy.
Yeah. So now, if, let me write down the problem first. Y is equal 3 to the power 4 minus x squared. Again, I'm going to use which formula? I'm going to use this one, the second piece. Now you don't have e. Instead, you have some other number. Now in this problem, a is 3. Do you see that?
Yeah.
Okay, I'm going to use that formula. Okay, so the formula I'm going to use here is the derivative of a to the u. This is simply a to the u times ln a times chain rule u prime. Right? So if you compare this formula here, a is what? A is 3. And what is u here? U is this
4
all.
minus x.
Yes. Now, if you want to apply this formula, you should know what? You should know u prime. U was 4 minus x squared. Then what is u prime? Simply the derivative of 4 minus x squared. The derivative of 4 is 0. Negative. The derivative of x squared is 2x, which is negative 2x. You see that?
Yeah.
Yeah, therefore, the derivative of 3 to the power 4 minus x squared is simply I'm using that formula. A is now 3, 4 minus x squared. U is 4 minus x squared. It times ln A. A was 3. Then times u prime. U prime was negative 2x. Okay. So if you rewrite, remember ln 3 is the constant. Negative 2. You could pull these all constant in front of the problem. Negative 2 ln 3. And x. Okay. Don't confuse. This is separate, no? Constant. So x times 3 to the power 4 minus x squared. See that answer?
Yeah, I see it.
Yes. That's about using exponential differentiation with chain rule. Are you getting?
Yes, sir.
What about another one? Who's that? One and who are they? A, B. Okay, so that's about number 2. Number 3, trouble. Finding the derivative of inverse trig, right?
Yeah.
Yeah, that's not easy, confusing. But anyway, keep your formula sheet with you to practice the problem.
Yeah, the formula sheet makes it. These.
Yeah, take a printout of the formula sheet and keep with you always.
Yeah, I actually printed out the one you posted.
That's nice. Okay. So, problem number 3. Before going to do problem number 3, let me show you the trig. So now we are where? We are here, okay?
Yeah.
The derivative of arcsine. Okay, this is the catch. Some of the textbooks, they use, instead of arc sine, you could use as sine inverse, right?
Yeah.
Same thing, right? So
Yeah.
arc sine x means actually sine inverse x. But no confusion, this is not the power negative one. This is different. This is inverse, okay? This is and this is are two different things. You
Yeah.
see,
One is in. Yeah. One is
this is
inverse.
inverse, but this is the reciprocal. If you see the negative one outside of the sign, that means it is a reciprocal, 1 over sine, which is cosecant, okay? But if you see the negative one inside here, somewhere here, that means that is inverse. Is that okay?
Yeah.
No confusion. So you could use, that is why most of the textbook, you know, they don't prefer to use these because of the confuseness. They use this. But anyway, I may use somewhere maybe like this sine inverse rather than
Yeah.
writing arc sine. It's easy, writing that.
Yeah. It is. I still
Yeah.
remember all that.
Right. So no confusion. That's what I want to tell you.
Yeah. I understand that part.
Yeah, good. So now within that, go to your formula sheet and check here. The derivative of sine inverse u is simply 1 over 1 minus u squared times the u prime. So if you have here x, you don't have u prime. U prime is just 1. Okay. So by knowing those things, if I write the formula somewhere here, let me write down. You could check. So the d over dx of sine inverse x is 1 over square root 1 minus x squared. If you have here u, then you have to replace here u and you will get here u prime. Okay. So d over dx of cosine inverse x is simply negative of the same answer of the above. And the derivative of arctan or tan inverse x is 1 over 1 plus x squared. And the derivative of cotangent inverse x is negative 1 over 1 plus x squared. And the derivative of secant inverse x is 1 over absolute. You should get here x squared minus 1. And the derivative of cosecant inverse x is simply the same with the negative sign. That makes sense?
Yeah.
All 6 trig functions. Right. So keep in mind those as well. Okay. So let's try a couple of problems from this. Which one you want? Okay, let me do last two. These two are kind of complicated, right?
Yeah. Is that
Okay. So I'm going to do part E first. So let me write down in inverse notation. I'm using inverse, sine inverse of square root 1 minus 4x squared. So now what is your suggestion?
what?
What is your idea?
Use that formula, right?
Okay, first you have to keep this as u, right?
Yeah.
Okay, so don't forget that. Use the u substitution first. So this is u. If that is u, what is u prime? Tell me. The derivative of square root 1 minus x squared. My u was square root 1 minus 4x squared. So,
That would be
yes,
2x
1 over the square root function derivative is always 1 over 2 square root of the 1, whatever you have
Oh, yeah.
inside. That's the easiest way, right? Then
Okay.
times the inside function derivative. The inside function derivative is what? What is the
8x.
derivative of 1 minus 4x squared? Yes, negative 8x. Derivative of 1 is 0, x squared is 2x, 2 times 4 is 8, but negative. So if you simplify this, 2 gone, you will get negative 4x, right?
Yeah.
That means negative 4x over square root 1 minus 4x squared. This is my u prime.
That's
Make
F
sense?
over 3e, right? Yeah.
Yeah, but remember, the formula is now for what? Y is equal sine inverse u. The question is finding the derivative of sine inverse u.
Oh, yes, that's B.
Formula says that, go back to your formula sheet. The derivative of sine inverse u is u prime over square root 1 minus u square. So this is u prime over square root 1 minus u square. Do you see that?
Yeah.
Okay, but we know everything now. What is u prime? Just now we got. U prime is negative 4x over
Square root of 1
1
minus
minus
4x squared.
4x. That is for u prime. But
Yeah.
I have 1 over square root 1 minus u squared as well. You could write this as u prime times 1 over square root 1 minus, right?
Yeah.
Then this u prime is here, and this is now u squared. My u was here. U was square root 1 minus 4 squared. That means what is then u squared? Let's see who's telling. What is u squared?
1 minus 4x squared.
Yes, without square root.
Yeah, it cancels out.
Cancels out. So I'm simply plugging those here. That is, in place of u squared, simply 1 minus 4x squared. You see that?
Mm-hmm.
That's it. You need to simplify now. So if you multiply the numerator piece, that is negative 4x over, this is square root 1 minus 4x squared, my first component, times, could you distribute inside? What will happen inside the radical here? 1 minus 1 gone, right? Cancelled. So you get minus into minus plus. You get simply 4x squared inside the radical. What is square root 4x squared?
Would it be
Square root of 4x squared. What is that?
2x squared?
2x.
Oh, 2. Oh, yeah, 2x.
You need to take the square for both, square root for both. Okay? So the square root of 4x squared means the square root of 4, which is 2, times the square root of x squared is simply x. Am I right?
Oh, yeah.
In another word, if you find the square of everything, you should get back to the original. Yes, 2 squared is 4, x squared is x squared. That makes sense?
Yeah.
Okay, now could you simplify further? What's happening
Yeah.
there?
Just bring everything together, start multiplying.
But you see now, x
Oh,
is
yeah.
cancelled, right?
Yeah. And you can simplify that negative 4, right?
Yeah, x gone. The
Negative
2
2.
negative 2 over. Makes sense, no?
Yeah, seems like a lot on
Right. So that was problem number 3, part E. Let me check my answer. Okay, so I'm going to do the last one, F, part F. Okay, so let me erase one more time. I need space. Now, the last one you see here, there are two functions now combined. One is arctan and one is ln. Find the derivative separately. That's it. So, problem number 3, part F, given by was arctan, I'm writing tan inverse 2x, minus 1/4 ln of 1 plus 4x squared, right? Now first I'm going to find the derivative of arctan. My u is now, what is u for the first piece? U is 2x, right? Simply find the derivative of arctan u. What is the derivative of arctan u? If you look at the formula sheet, it should be u prime over 1 plus u squared. Am I right?
Yes.
Okay. That is for first piece, for this piece. For the second piece, again you have to use the ln u. Again, this is u. For the second piece, answer is 1/4. The derivative of ln u is 1 over u times u prime. Okay, no confusion, two different u's, right? Okay, for the first piece, u was 2x. Therefore, u prime is the derivative of 2x, which is 2, right?
Yeah.
and over 1 plus u squared. U was 2x. Therefore, no
2x
confusion,
squared.
2x whole thing squared. That is my first piece. For the second piece, 1/4 times, now my u is different. U is 1 plus 4x squared. Therefore, the derivative of 1 plus 4x squared is simply 8x, right?
Yeah.
Yeah, the u prime here is 8x over u was 1 plus 4x squared. You see that? Now you need to simplify. Could you simplify? First one, 2 over 1 plus, if you expand, this will be 4x squared minus this 4 and 8 gone, 2, right?
Right.
That is 2x over 1 plus 4x squared. Yeah, we are happy. It is very easy to simplify. Why? Because you have same denominator, right? Then simply you put at the numerator 2 minus 2x under the 1 LCM. Now you could take 2 as a common factor. So you still get 1 minus x over 1 plus 4x squared. You see that? Okay.
Yeah.
So that is about finding the derivative of inverse 3.
Yeah. Just having the this is the function. The function of the paper.
I cannot hear you. Now number 4, finding dy over dx. It's kind of, this is called, the implicit differentiation, right? Do you see that implicit differentiation? You might have seen in Cal1, right?
Yeah.
Your question is what? Finding dy over dx. That means your task is to find y prime. So your task here is to find dy over dx means y prime, right? Find y prime. Your y prime answer may be with x and y. Y also may be there inside your answer. Okay, no problem. So your task is to find now y prime in terms of x and y. Okay, so let me do both of them. Problem number 4. Part A, ln x times y plus 5x, which is 30. What is your task? Task is to find y prime. Simply use the logarithm properties here. Log a times b is log a plus log b, right?
Yeah.
Then I'm rewriting the problem. Now I'm taking the derivative with respect to x.
X.
Take the derivative with respect to x. So that means find the differentiation for each function with respect to x. The derivative of ln x is 1 over x. But here's the catch. Here you have to use the chain rule. Why it is? Because you don't see here x. So you could think of this is like a u, right? U function.
So the 1 over y times y prime.
Exactly. 1 over y times y prime. Your y is now u.
Plus
Plus the
I.
derivative of 5x is 5 equals
0.
0. The derivative of constant is 0. So what is your task? Your task is to find y prime. So solve this equation for y prime. So move these two guys to the right. So I'm moving 1 over x and 5 to the right. That means left side will be simply 1 over y times y prime. I'm moving 5 and 1 over x to another side. You will get negative 5, negative 1 over x. Right? So I'm solving for y prime. So multiply by y both sides. So you will get y prime as y times negative 5. Okay. So could you simplify? So if you want, you could move that negative sign. Yeah, you could move that negative sign outside if you want. So you could keep 5 plus 1 over x. Or I think my answer is, let me check the answer I gave you. Yeah, in that answer, we have cross multiplied and combined these two, right? So you have 1 here, so cross multiplied 5x plus 1 over x. this is the answer you see in the answer key. But at this point, also fine. Don't need to simplify. You could leave like this.
Okay.
Okay. That is there. That was first part. Second part. Sorry. Tan inverse arctan of x plus y, that is y squared plus pi over 4. Do the same thing. Oh, now you need to use the chain rule inside, right? You could think of this all like u. Okay, this is like u. So the derivative of arctan u, what is that? One more time, I'm writing u prime over 1 plus u squared, right? Remember, we are taking the derivative with respect to x. Therefore, the derivative of y squared is what?
2.
Y times y prime, right?
Right.
You could think of this as like u squared. So the derivative of u squared 2u times u prime. Then plus the derivative of constant, pi over 4 is constant, which is, so now your task is to find y prime. First of all, let us figure out this guy. What is u prime here? U was x plus y, right? Then what is u prime? What is the derivative of x? 1 plus the derivative of y with respect to x is y prime. Alright? This all over 1 plus u squared. Our u was x plus y, but whole thing squared. This would be equals to 2y times y prime. My task is to find y prime, therefore I am dividing by 2y both sides. Okay, I am dividing by 2y both sides. Use the different color. So I am dividing by 2y both sides. To cancel, right? Therefore, what is y prime? This side I have only y prime. So y prime is simply 1 plus. Here also I have one more y prime, right? Isn't it? Okay, doesn't matter. First, which one is the easiest way? Okay, so y prime equals 1 plus, let me write down one more step. What is our task actually? Task is to find y prime, right?
Yes.
That means you need to cross multiply, no? So y prime 1 plus x plus y, all things square, I'm simply multiplying. That should be equals to 1 times of that. You see that? Now I am writing all the y prime terms one side. Move this y prime to another side. Equals 1. Now y prime is the common factor between these two. I'm taking y prime as a common factor. So 1 plus x plus y squared minus plus 1. Sorry, the mistake I'm making here.
Did you have to cross multiply?
Oh yes, oh I missed this one, right? Where's 2y? We need to make cross multiplication. Yes, you have to solve for y prime, right?
Oh yeah.
So I missed that 2y. Where's this 2y? So I'm cross multiplying. Y prime is here. 1 plus y prime, this is here. You see now, I'm missing 2y. This 2y also there, right?
Yeah.
Okay, now when you cross multiply, okay, so now I'm cross multiplying these two. So you will get y prime times 2y times 1 plus x plus y whole thing squared, that is left side, equals 1 plus y prime. Now move this y prime to the left side, so you will get y prime 2y times 1 plus x plus y whole thing squared, subtract y prime, which is 1. Now take y prime as the common factor, so you will get 2y 1 plus x plus y whole thing squared, subtract 1 equals 1. Okay, so we are solving for y prime, then divide by both sides. Yeah, then divide by 2y 1 plus x plus y squared. Okay, therefore this term gone, so y prime is 1 over 2y and 1 plus x plus y squared. Okay, so that is there. So you have more algebra work here, right? From here to here.
Yeah.
If you look at my answer key, I just have distributed inside. So you'll have 2y plus 2y times x plus y whole thing squared minus 1. Your answer C. Okay, that is there. Now, number 5, finding a tangent line. Do you know how to find the tangent line at the given point? Cal1.
Yeah. Don't you use that like y1 minus y equals x?
Equals y prime times x minus x1. You need to find out the derivative of the function first.
Oh,
Okay?
yeah. To find
Remember?
slope, right?
Yeah, slope. The slope of the tangent line is nothing but the derivative of the function evaluated at the given point, right?
Yeah.
So basically the slope means the derivative of the function, first derivative of the function. Okay, so there are two problems here. Let me do only one here, but next one you could try and you will see the answer. Okay, so let us try the first one. Find an equation of the tangent line. So what is your task first? First of all, you need to find what? You need to find the slope. Slope of the tangent. Slope of the tangent of the given graph y is simply dy over dx at the given point, right? At this problem, right? So I'm doing problem number 5, part A. You are asked to find the tangent line at the given point -1, 1. That means your task is to find the y prime evaluated at -1, 1. Remember, first coordinate is x and the second coordinate is y, right?
Yeah.
Okay. Now your task is to find dy over dx. Dy over dx is simply y prime. First find the y prime by using the formula, then plugging these two values for x and y and find the slope. So this is basically the slope of the straight line, right? So this is nothing but, in our notation we use for the straight line slope is m, right?
Yeah.
That means once you know this m, after evaluating values, you should simply y minus y1, this is my x1 and y1. M times x minus x1, that's it. So you need to find like this formula, right?
Right.
Okay, so first my task is to find m. So you need to find the derivative. So the given problem, let me write down the problem first. 2x cubed plus ln y squared plus 2y equals 2 times x plus 1. So the given point was -1, 1. So this is my x1 and this is my y1. So I'm finding the derivative first. Take the derivative. With respect to x. So simply find the derivative one by one. So the derivative of 2x cube is going to be Yes, 2 times the derivative of x cube is 3x squared. Yes.
Oh yeah. No, isn't it? Oh
Yeah,
yeah.
6x squared, but I'm writing it this way.
I see what. Yeah, I see what you're doing. My bad.
Yeah. Plus the derivative of ln, this is u, so 1 over u times u prime, that means the derivative of y squared, which
2.
is 2y times, again one more chain rule, we are taking with respect to x.
Oh, so be just y1.
This is the place most of the students make mistakes. So here you have to take 2 times, right? Chain rule.
Yeah.
One chain rule for ln function, another chain rule for y squared function. Okay?
That's when it's like when you have both x and y, you do that right there for
Yes.
when you have respect to x.
Right. Because with respect to x, we are taking
So it's dy over dx. Okay.
dy over dx. Yes, that is my y prime.
Yeah, I remember in
Okay?
Carol 1, I had a hard time like
You are true.
understanding it
You
at
are
first.
true. Yeah. When we were studying this in high school, we were also in trouble. It took time while to understand. So this is our u, ln u. Okay.
Yeah.
Right. That is there. So that is my ln y squared derivative. Don't forget, you have one more. That is the derivative of 2y, which is 2 times y prime, right? That side, easy. 2 times the derivative of x plus 1, which is simply 1, right?
Yeah.
So which is 2 times 1.
Mm-hmm.
Now, what is your task now? Finding y prime, right? You don't need to solve for y prime because it will be messed up. You have a lot of work. If you try to find y prime at this point, you will be in trouble. Instead, plugging the values first for x and y, then you will get number over there, then very easy to find y prime. Okay? So now at this point, what I'm going to do is I'm going to plug in the values. You know the values, right? The values of x and y. My x is here, the point is -1 and 1, right? So x is -1 and y is 1. My task is to find the slope y prime evaluated at -1, 1. So simply I am plugging -1 and 1, you know, at this equation to find y prime, okay? Wherever you have x simply replaced by -1 and y is replaced by 1.
Yeah.
Therefore, 2 times 3 is 6, x squared, x is -1, put the square like this, you have to put the parenthesis, plus 1 over y is now 1, so which is 1 squared, times 2, again y, 1, times y prime. My task is to find now y prime, plus here also 2y prime equals 2 times 1, which is 2, right?
Yeah.
Yes. Now what is your task? Simply find y prime from here. Easy. So now -1 squared is 1. 1 times 6, which is 6. Plus, okay, so be careful. These all together one number, right?
Yeah.
So 1 squared is 1. 2 times 2. 2 times y prime. So you will get here just
2y prime.
2y prime. Yes.
Did you not forget the x? Oh no, you plugged in x. My bad.
Yes, yes.
Or 6.
Now again 2y prime, which is 2. Now 6 plus 2y prime plus 2y prime is 4y prime, which is 2, right?
Yeah.
Okay, now it's very simple to find y prime, right? Solve for y prime then.
Equals -1.
Let's see. So 4y prime, 2 is here, move 6 to the another side, that is -6. Yeah, you are correct, that is -4. So 4y prime is -4, therefore y prime is -1. That means what? That means the slope of that particular tangent line is simply -1, right?
Yes.
That means this is nothing but what? My m.
Yeah.
So that's simple now. You know point and the slope, use the formula. Therefore, the tangent line formula says that y minus y1 equals m times x minus x1. x1, y1 are the given coordinates, right?
Mm-hmm.
Okay, y minus y1 is 1, m is -1, x minus x1 is -1, right?
Yeah.
Now, simply find out this part, x plus 1. Now multiply inside. you will get negative x minus 1 minus 1. So both sides minus 1 gone. So answer is y is equal negative x. That's correct.
Okay. Makes sense.
Yeah. Okay. Any questions so far?
Mm-mm. And for the ones with under number 6, they're the same thing, but logarithmic.
Yes. Take the log both sides. I think we have enough problem done in this one from your class notes.
Yeah. I
Okay.
think we could just go ahead and move on to number 7.
Yes, take the ln both sides and find the logarithmic differentiation. So your solution will be given later, okay? I will give you. Yes.
Does this thing you're doing right now cover all of chapter or unit 1 or unit 5, I meant?
Which one you are talking about?
Like everything
We are
within
covering everything from 5.1 to 5.8.
Okay.
I appreciate it.
Yeah. Anything else? So now you want what? Number 7, right?
Yeah, and at least one of them like number 8 through 9.
Okay. Oh, you see now? This is what? From where are you getting these all problems? Coming from what?
5.6.
That is L'Hopital rules. Okay?
Say what?
L'Hopital rule.
Oh, okay.
That is from 5.6. Let me check. This is the section, okay?
Yeah.
So this is called a L'Hopital rule. So I just briefly explained today, right? So, okay, this is about the L'Hopital rule, okay? What is the scenario we use? If you find the limit for the problem, if you come across like a 0 over 0 or infinity over infinity, then you have to use the, the L'Hopital rule. Simply, if you want to find the limit of this, simply find the first derivative of these two, plug in, then find the limit. Okay? That makes sense?
Yes, sir.
Yeah, for example, how do you find the limit of sine x over x when limit x goes to 0?
You'll take the derivative, right?
That's it. If you plug in 0 right away to these two functions, sine 0, you will get the numerator and the denominator 0. Sine 0 is 0, but the denominator is 0. That means we cannot find the answer. This is called indeterminate form, right? So whenever you have indeterminate form, you cannot find the answer. So this L'Hopital rule says that it is very easy. Take the numerator function as f and take denominator function as g. Now, the finding the limit of this problem is equivalent to find the limit of the first derivative of these two functions. Simply find the derivative of sine x, which is cosine x, over the derivative of x, which is just 1. Right? Now it is very easy to find the limit. What is the limit of cosine x over 1? Simply plugging 0 now. What is cosine 0?
It's 1.
1. 1 over 1. Now you are getting very good number. Isn't that? Therefore, you use like this L'Hopital rule whenever you have 0 over 0 or infinity over infinity. Both of them are okay. Now remember, go back to Cal 1. You learned one formula or theorem. Remember, limit x goes to 0 of sine x over x is 1. Do you remember that? This
Sine
was
x.
a theorem you learned in Cal 1. You did not study why you got 1, but now you are seeing this is the the reason why you are getting 1, limit x over x. Okay?
Makes sense. Yep.
Because of the L'Hopital rules. Okay, so this is the, now there are some problems. These are the scenarios indeterminate. These are the scenarios you use L'Hopital rules. Suppose if you see 0 over 0 or infinity over infinity. Okay? But there are some cases you will come across like infinity minus infinity. Or you may see like 1 to the power infinity, or 0 to the power 0, or infinity to the power 0. These all called, indeterminate form, everything, okay? So if you see any one of these kind of, form in your limit, that is called indeterminate, okay? But this L'Hopital rule provides the things only for 0 over 0 or infinity over infinity. Once you have the problem in the remaining forms, right, you have to rewrite the given problems for this kind of scenario into that. Once you have written all these kinds of scenarios into the previous, then you are good to use the the L'Hopital rules. That makes sense?
Mm-hmm.
Okay, for example, let me check one easy problem. What one is the easy one? Okay, look at this note. This is about the the indeterminate form of either infinity minus infinity or infinity times 0 also possible. Okay, I did not include that. So infinity times 0 also possible. We may have plus or minus here. Okay, this is also indeterminate form. So if you have such a form, use some techniques and try to write down the given problem in 0 over 0 or infinity over infinity. Look at this problem. How do you find the limit of this? X times tangent 1 over x. If you plug in infinity to x, you will get infinity times tangent 1 over infinity. I'm simply plugging infinity here. What is 1 over infinity? Any number over infinity is 0, right?
Oh. Oh, well, yeah, because it approaches 0.
Yes. So that means this is nothing but infinity times tangent 0. Tangent 0 is 0. Therefore, you are getting one kind of, indeterminate form, which is infinity times 0. If you have such a problem, you try to write down the problem in terms of 0 over 0 or infinity over infinity. Look at the work we have done. We did some algebra. Remember, this is just a number. Under everything here, we have just 1, right? We don't write. If you play a little bit around, you could move this x to the denominator by plugging into 1 over x, like this. What I'm trying to say is 2 could be written as 1 over 1/2. You're correct. Do you agree with me? 2 is 1 over 1/2.
Yeah.
How did I do that? I have simply 1 here. I'm moving the numerator to the denominator by 1. Same thing happening here. I'm just moving x to the denominator by putting 1 over x. So like that, I could rewrite. Do you see that?
Oh, yeah.
Now if you're plugging infinity to this, numerator and the denominator, what you'll get? Now if you plug infinity, tan 1 over infinity is tangent 0. Now the denominator also 1 over infinity. Now you are getting 0 over 0. You see that?
Mm-hmm. Yeah.
Okay. Once you have 0 over 0, now you are going to use what? L'Hopital rule. L'Hopital rule says what? Take the numerator, find the derivative, take the denominator, find the derivative, then plugging the limit. That's what we are doing here.
So you'll find the derivative of each one separately, right?
Separately, yes. No quotient rule. Don't mess up. Just find separately. So we are finding here the derivative of tangent 1 over x. The derivative of tangent 1 over x is what? Simply use the chain rule. This is u. So the derivative of tangent u is what? Secant squared u. Okay? Then u prime. The derivative of 1 over x is negative 1 over x squared. Simply we are finding the first derivative of tangent 1 over x here. We are doing the same thing for 1 over x. The derivative of 1 over x is negative 1 over x squared. Now we are plugging the limit and checking whether we are getting good number. Now you should get very good number. That number is 1. So this is easy. So my suggestion is, do more problems on L'Hopital rules on 5.6 from your textbook and check. You all have answers for hard problems, am I right?
Yep.
So then why don't you try all the hard problems, make it familiar, and then once you do more problems, then yeah, unfortunately for Cal 2, you had to work a lot. Okay, does that make sense?
Yeah.
Okay, now look at this problem. What is the scenario I have here? If you're plugging 0 right away, what you'll get? 1 over sine 0. Sine 0 is 0. So 1 over 0, which is infinity. This is getting now infinity. What about the second piece? When x goes to 0, again you are getting 1 over 0, which is infinity. Am I right?
Mm,
So here
yeah.
you are getting now infinity minus infinity. This is also considered as indeterminate form. Okay. Now, once you see these kind of things, what is your task? Your task is to use some algebra or some other techniques to write down infinity minus infinity into either 0 over 0 or infinity over infinity form. Once you rewrite this into that, then you are good to use the L'Hopital rule. That makes sense?
Yeah. Okay.
Right. Now we use simple algebra, right? So you see now simply you find the LCM of these two numbers, that is just a product of these two, x times sine x. Then we simply cross multiply these and that. So 1 times x is x, subtract sine x times 1, which is sine x. Now you see earlier you had a minus sign in between two functions. Now I have put them into fraction form, right?
Mm-hmm.
Now if you're plugging the limit, what you'll get? Plugging the limit to the numerator and denominator separately. If you're
0
plugging
times
0, yes, 0 minus sine 0, 0. You are getting now 0 in the numerator. What about the denominator?
0 times sine x 0 0.
Again, you are getting 0 over 0. That means now you are good to use what? We are good to use
Lop-
L'Hopital rule, yes. What does that means? Simply find the first derivative of numerator and the denominator separately, then plugging 0 and check. Make sense?
Yeah.
Yes. Now we are finding the derivative of first, the numerator. What is the derivative of x, which is 1? The
Mhm.
derivative of sine, which is cosine. Now, finding the derivative of denominator is kind of tricky. Why?
Let's see. Chain rule.
Chain
No,
rule?
no, product rule.
No, product rule. Use
Yeah.
the product rule. You have now two functions with product sign. So you could think of this is like f and this function is like g. So f times g prime plus g times f prime, right? The product rule, Cal 1. So g times g is sine x, g times f prime. The derivative of first function is 1. That is why you have here just sine x. Now again here f times g prime. F is x times g prime. The derivative of sine x is cosine x. Do you see that?
Mm-hmm.
Okay. Now simply plugging the limit and check 0. Yes? Oh, you see now. Forget about this step, okay? Look at here. When you're plugging 0, what you'll get the numerator? Tell me.
1 minus 0 is 1.
No? Cosine 0 is 1.
Oh, 1 minus 1 is 0.
0. What about the denominator?
Sine x is 0. 0 times cosine 1. It's still 0, right?
You see now. Again, we are in trouble. Again, we are getting 0 over 0. That means keep on doing. One more time, derivative of the numerator. Okay?
Yeah. So
Yes, the derivative of 1 is gone, constant. The derivative of cosine is negative sign, but here you have minus sign. It will make you positive sign. Is that correct?
Yeah.
Okay, I think they missed here one limit sign. It should be limit x goes to 0 of that. So this is missing, okay?
Yeah.
Now take the derivative of the denominator one more time. Sine x, the derivative of cosine. Okay, again you have to use the chain rule. Product rule. So let us find the derivative of the denominator here. Let's see whether we are getting this answer. So I'm asking you, hey, could you find the derivative of this sine x plus x times cosine x? Yes, the derivative of sine x is cosine x, right?
Is it not negative cosine x or just cosine x? I think
Just
it is, yeah.
cosine. Just cosine.
The derivative for cosine x is negative sign, right?
Right. So
Okay.
the derivative of sine x is cosine. The derivative of cosine x is
Negative sine x.
negative sine x. The derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. Why I am writing this all? This is the way to remember. Whatever you have the trig starting with letter C, always have negative sign.
I see.
So you don't forget hereafter, okay?
Yeah.
Remaining all positive. That makes sense?
Yes, sir.
Okay, good. So now let's move here. The product rule one more time. This is my f, this is my g, right? So x times the derivative of cosine is negative sine x
Negative sign, yeah.
plus cosine x times, yes, the derivative of x is just 1. Now when you combine cosine and cosine, you will get
2
2 cosine.
cosine x.
You have here negative sign, pull into here, you will get negative x sine x. That is why you have there here, okay?
Yeah.
I am messing up everything here. So take your pencil and write down here x goes to 0, missing limit. So now you see why you have here 2 cosine x minus x sine x because of this reason. Okay.
Yeah.
Now plugging the limit 0, what you'll get the numerator?
1.
No, sine 0.
Oh, sine 0, yeah.
0. But the denominator is now good number. Why? This guy is 0, but here you will get what? 2 times cosine 0, which is 2, right?
2, yeah. 2 minus
Now
2.
you don't get 0 over 0. You are getting good numbers. 0 over 2, which is
0.
0. You see now?
Yeah.
Until you get the good number, you had to keep on applying L'Hopital rule several times. Very interesting, right?
Yeah. And for one last time, cosine 0 is 1, right?
Yes, you go and check your unit circle.
Yeah.
Okay. Cosine. Yeah, in the formula sheet, you already have that also. I have included.
Yeah. Yeah.
Yeah, sorry for that. You need to remember lots of things.
Yeah.
But you know, you don't need to buy hard. When you do more problems, it will be registered in your mind.
Yeah, it'll come more naturally.
Yeah. You see, I'm not seeing all the formula. I'm familiar. Why it is? Because I have done a lot of problems, right?
Yeah. You memorize them now.
So that is there. Okay. So, oh, this is the most important part.
Then the indeterminate form.
Oh, this is another kind of indeterminate. What is that? When you do the problem plugging, if you see 1 to the power infinity or 0 to the power 0 or infinity to the power 0, these all three are indeterminate. Again, use some technique and write down that into 0 over 0 or infinity over infinity. Okay? When you see this type of three, exponent things, you will see always two functions in the problem. Like they will give exponent function. One is here and one is there. Right? So in the problem, you will see like exponent function. You will be finding limit. This is the way. If you see one of these kind of, in determinant form, you follow these 4 steps. Okay. What you want to do is you simply, find the limit x goes to z of ln of this function. Simply put ln and find fx dx. The original question will be fx to the power gx, but once you see indeterminate form, try to find the limit with ln, okay? Remember, we have logarithm property, right? If you have power inside the ln, you could pull in front of the function. So this could be written as x goes to c of gx times fx. Oops, I forgot ln. ln of fx, right? Now, if you plugging, c into this function, you should be able to see either 0 over 0 or infinity over infinity. Then use the L'Hopital rule for this guy and find the number L. Okay, I will explain one problem here. After finding that limit, to find the original problem, remember in your original problem, you did not have ln, right? The original problem will be like this without ln. But I only put ln and did the problem in such a way. Why I am doing? Because to, approach the problem in easiest way. Once you find the limit of, ln fx to the power gx, get that number. After getting that number, to get the final answer, limit x goes to c of f to the power g is simply let the number e and put that power l. Whatever you got that answer, put here with the e power. That make sense?
Yes, sir.
Okay, so that is the one here you have. When you go through this and watch the videos, and you will understand clearly. Okay.
Mm-hmm.
Right. So this all about that, explaining 0 over 0. I will take one example from your, test. Then we will look at that. Oh well. Okay. Where's that test problems? Let me go back. We are here, right?
Yes.
So are you okay? You have enough time? Or maybe another 30 minutes? Or do you want me to stop, or what do you want?
30.
If you want, I could explain now for a couple of problems here up to 3:30, or otherwise I will post all the solutions. And will you able to watch your videos for these all sections and check my solutions?
I mean, yeah, we can. Well, another half hour.
What about the other one? Who's that?
Tony, what you think?
Yeah. It don't matter. I'm just trying to soak it up enough.
I can shoot
Repause
one problem or
myself.
so.
Okay, so that means let's go a little bit quickly and finishing.
Yeah.
Okay, now tell me. Let me think about. Look at part C.
Part C. Yeah.
What kind of scenario you have now? When you're plugging infinity, what you'll get?
0.
Where you will get 0?
The what?
Where do you get 0? Tell me the final answer.
For part C, you'll get 1 plus 1 over 0, which is, oh, it's,
Tell me now. You are in trouble now, right?
yeah, that's undefined, right?
Right. When x goes to infinity, you will get here 1 over infinity. 1 over infinity is 0. So 1 plus 0 is 1. So you will get 1 inside the parentheses. Am I right?
Mm,
But you see outside in the power you have x. When x goes to infinity, that will be infinity. Am I right?
yeah.
That means you will get the form 1 to the power infinity. Is this good number or indeterminate form?
Indeterminate.
Yes, you look at the notes there. 1 to the power infinity is indeterminate form. So you may think that 1 to the power any number is 1. But for infinity, that is not the case. Okay?
Okay.
So you need to find the answer. That means what? You have to use which technique? Just now I explained you.
L'Hopital rule.
L'Hopital rule, but the guides now you have 1 to 4. You have to follow that. So remember, the given problem is always in this form. F to the power gx. Okay.
Yeah.
So what is your f here in this problem? F is the down function. This is f. This is g. Okay. So here fx is 1 plus 1 over x, and gx is just x. Always write the given problem in the form of f to the power g. Okay. So this is G, this is F.
Mhm.
The guide says that if you want to find the limit of F to the power G, simply consider the limit of x goes to infinity of what? Ln fx gx. Okay.
Okay.
Now by using the log properties, this could be written as limit x goes to infinity, move this power into in front of the log. So you could rewrite this as gx times ln fx. Okay.
Yeah.
Now plugging the functions g and f. What is my f function here in this problem? What is my g? My
Your
g was
is-
simply x, right?
Yeah.
What is my fx function?
1 plus 1 over
1
x.
plus 1 over x. Remember, you have here now ln,
Yeah.
right?
Differentiate it.
Just a minute. Now you need to rewrite this as a fraction, right? Remember, always you have to write the fraction f over g form. You have to write like a fraction now. How can I
Okay.
write these two like a fraction? Remember, I just now explained you could move x to the denominator and putting by 1 over x. Does that make sense? I'm rewriting these as like this. Do you see that?
Mm-hmm.
I am moving x to the denominator of this all. You have 1, right? Now plugging the limit and check. When x goes to infinity, what will happen to the numerator?
Um,
When x goes to infinity, 1 over infinity, this is 0. You will get simply ln 1. What is ln 1?
ln1 is
You had the properties of natural logarithms in
0
first
over
chapter.
1.
So I'm just simply asking what is ln 1? Ln of 1 is always
0.
0. Yes. Keep in mind that, okay? So when you plug in x infinity to the problem, the numerator is going to be 0. What about the denominator? When x goes to infinity, 1 over infinity, which is
1 over infinity.
0.
Oh.
1 over
Oh, yeah,
infinity
yeah,
is 0, right?
Yeah, I'm doing all right.
Yeah. Does that make sense?
yeah. So you gotta keep going. Oh, that you can take that, right?
Yes, now you are getting 0 over 0 form, right?
Yeah.
Now take the derivative of, numerator and find the derivative of the denominator.
Okay. So
So now you have more work. You have to use the chain rule. Inside the ln, this is u, right?
yeah, so that'd be 1 over
1 over u. U was 1 plus 1 over x, right?
Yeah.
Times u prime. What is the derivative of 1 plus 1 over x? Your u was 1 plus 1 over x. Then u prime is simply the derivative of 1 is 0. What is the derivative of 1 over x?
Negative x.
No, you are very close.
Uh,
How do you find the
oh,
derivative
just
of
negative 1
1 over
x.
x squared? You remember this formula. The derivative of x to the power n is n times xn minus 1.
Yeah. Oh,
Right? Now the question is 1 over x. 1 over x could be written as x to the power negative 1, right?
yeah.
That means n is negative 1. Simply plugging here negative 1 to find the derivative of 1 over x, which is negative 1 times x. N is now negative 1. Negative 1 will be negative 2. If you move to the denominator, it will be positive 2.
Yeah.
Okay, so u prime is negative 1 over x squared. So this is the answer you get for the numerator derivative, right?
Yeah.
Now find the denominator derivative. Again, 1 over x, the derivative of 1 over x is negative 1 over x squared. Just now I explained, right? The same thing.
Yeah.
Now it's easy. These two going to be cancelled,
Right.
right?
Correct.
Now plugging the limit, what you'll get?
1 over 1 plus 1 over x is, so 1 over infinity plus 1, it'll be 1 over infinity.
No. You see, you're plugging infinity here, right?
Yeah, so it'll be
Then
1 over
1 over
infinity.
infinity. So this fraction will be 0.
Oh, yeah. Jesus.
So this is 0.
Yeah, 0. So it'll just be 1.
1 over 1, which is 1.
Oh, yeah.
Right? So
Yeah.
find like this one number. How did you find this number? This number is nothing but limit of the problem, but gx time ln fx. After finding this number, this is my L. Okay? If you look at the guide telling that after getting L, simply plugging that L value to the power of E. L is now 1. This is my L. Okay? Therefore, the limit of the problem x goes to infinity of 1 plus 1 over x to the power x is simply e to the power 1. E to the power 1 is simply e.
Okay.
So,
Now, say infinity over 1 is infinity, right?
infinity over 1 is infinity. 1 over infinity is 0. Yeah.
Okay. And like, well, actually, infinity over any constant, like any number, would be infinity still, right?
Yeah.
Okay.
But that number should be positive. Suppose if you have negative number, then infinity will be negative infinity.
Yeah.
So do you understand now?
Yeah.
More work, yeah. So my suggestion is, watch the videos and get familiar. You are going to have similar problems in the test, okay? Right. So why don't you try, using L'Hopital rules? The first one is very simple: 0 over 0. Find the derivative both, then plugging. Second one also 0 over 0. Third one is the one I just explained you, using power. Next one also power. So C and D are similar. Use the same technique, and why don't you check? And I'm going to give the answer so you could think of that. Okay.
Okay.
Right. The next one, what kind of E? If you're plugging infinity, this piece is going to be infinity. But the first one is, you see the negative sign here?
Be negative infinity.
Yeah, 1 over
Well,
e to the
over
power
negative.
positive infinity. So you get, when e goes to infinity, you get here 0. You get here infinity. Do you see that?
Yeah.
Okay, that means you get what? You get 0 times infinity form. So you have to rewrite, move this guy to the denominator, and you rewrite like 3x squared plus 1 over e to the power 2x. Now if you're plugging the value, you will get infinity over infinity form. So use the L'Hopital rule. Just find the derivative of these two, and you should be good. Okay. Okay, that's all there. And right. So now for the integrals, simply you have to use the u substitution. Okay. So simply I'm giving hint, and why don't you try? Number 8 is about using u substitution. So I'm writing here to take the first part A, take u as the denominator 2x to the power 4 minus 3x, and for part B, take u as x minus 2, and for part C, take u as ln x. Okay. And for part D, there are two things. Of one is use the long division. Okay, to write down t squared plus 4 over t plus 2. Right. If you use the long division, this could be written as what? Do you remember the long division? So I could rewrite t squared plus 4 if you divide that by t plus 2. So you could match t squared with t, putting here t as a quotient, just multiply. So 2t, then you need to subtract. When you subtract, you should get 4 minus 2t. Then you need to get negative 2t, so you have to put here negative 2. So we'll get negative 4 and negative 2t. So when you subtract, this is gone. Subtract, this is gone. So you will get simply 8, right? Remember, when you do the long division, the number you get, which is the remainder, and quotient, right? Okay, so this could be written as a remainder. The quotient, I got t minus 2. So remember, if you divide one function by another, you could write always quotient plus the remainder over the dividend, which is the divisor, which is t plus 2. You know how to write these things? Have you learned this?
I've never seen it used like that or ever used like this.
Oh, so this is the easiest way to, what I'm trying to do is here, I'm trying to, split the given function into two easy pieces, right? If I could write like this, now finding integration is very easy, right? The question was finding the integration of t squared plus 4 over t plus 2 dt. I'm talking about part D. So by using this long division procedure, I could rewrite, the given problem as now t minus 2 plus 8 over t plus 2, this all dt. So you could split the problem into two pieces and, you could do that. So now you could just write this as t minus 2 dt and plus 8 over.
My mother calling, so I'll join back.
Yeah. Yes, no problem. Okay. So now use the U substitution for second piece. First piece is easy, right? Finding the integration of t is t squared over 2. The integration of 2 is 2t. Plus here use the, U substitution. Take u as t plus 2. Then you will get for sure that is 8 times ln 8 t plus 2. Okay. Plus c. So this is the answer. That is why I just used that technique. So if you do not see that, it's fine. You could just simply use the basic thing, whatever. So let me explain that suppose if you want, you could take t plus 2, right? The second method is let u as t plus 2 like our normal method, okay?
Yeah.
If this is the case, what is du? Simply dt, right?
Yeah.
That means you need to change all the variable t variable into u variable. Okay, the thing is now you should be able to rewrite t squared plus 4 in terms of u. Remember my u was t plus 2. This will give you, right? This will give you t, which is equals to u minus 2. If you solve this substitution for t, you will get t is u minus 2, right? In other words, if you move 2 to the left side, you will get t, which is u minus 2. Do you see that?
Yes, sir.
Yeah, that means in place of t, you could replace by u minus 2.
Yeah.
That is my t, yes, that is squared. Plus 4 over my t plus 2 was u. And my dt was du. Now, how do you integrate this? You have to expand, right? Expand it. U minus 2 whole thing squared is nothing but u squared minus 4u plus 4. You know how to expand this, right?
Yes, sir.
Then plus you have constant 4 over u times du. Now combine all the terms. 4 constant, you will get u squared minus 4e plus 8, right?
Yeah.
Now split this into three different integrals. U squared over u minus 4u over u plus 8 over u. Okay?
Yeah.
So then first one is simply u du. The second one u gone just a constant. And the third one is 8 times 1 over u. First one is u squared over 2 minus 4u plus 8 ln u. What was your u? Your u was t plus 2, right? Do you see this?
Yeah.
This is my second method.
Yeah, I think I like this one better.
It's up to you.
And do you
Okay.
distribute after that, or
And then this is fine. You just leave it
that's
like
fine
this.
right there?
Yeah.
Okay.
But if you simplify this and once you simplify these two and combine with a -8, you should get this answer. But I prefer this because, yeah, after getting some practice, you will learn this kind of techniques. You see, just the 2 steps, right? Here I did this
Yeah.
method, just few
Oh.
steps. Here you have more steps. But anyway, second method is very much understandable, right?
Yeah. Well, I mean, I'm trying to look back at that video and see how
Yeah.
you did it again. Number
Yeah.
one, or that first method.
Right. So now I think now almost time is up. So